loops paper here. Alright, so here is what we had. Negative 2 minus 12y plus 12x times negative 2x over 1 plus 6y all over 1 plus 6y squared. Okay, so we had gotten here yesterday, and I said on a free response question, this is perfectly acceptable. Okay, so everybody should have your notes out. We're looking at this question. So this is perfectly acceptable. If it is on free response, you are going to stop at this point. However, if it is not on free response, then you may have to simplify it. So this complex fraction, we don't like to have complex fractions. So we need to do something to get rid of that complex fraction. So I think what I'm going to do is write this like this, negative 2 minus 12y minus 24x squared, because this will be over 1. Right, I'm going to put these two together because they're multiplied together, over 1 plus 6y. I'll put all these over 1, and that's all over 1 plus 6y squared. And so I think I'm going to go the common denominator route here. So you need common denominators in that we're only really looking at the top part of this complex fraction. So we're looking here. We want to get common denominators there, so we need a 1 plus 6y. So 1 plus 6y on top and bottom. Of this. And so I'm going to go ahead and distribute here. So I will get negative 2 minus 12y. We'll distribute here. Minus 12y minus 72y squared. And then I've got that minus 24x squared all over 1 plus 6y over 1 plus 6y squared. This bottom fraction, we can think of this as being over 1. We got dividing fractions, easy as pie. Flip the second and multiply. I'm also going to simplify this top just a little. I've got negative 2 minus 24y minus 72y squared minus 24x squared over 1 plus 6y times 1 over 1 plus 6y squared. So if we multiply those together, we will get negative 2 minus 24y minus 72y squared minus 24x squared all over 1 plus 6y to the third. Did it take a whole entire page for you by the time you're all the way done? If you simplify these, sometimes these will, because you have to find that the first derivative is a lot of work to begin with, and then you've got to do the second derivative on top of that, which is usually more complicated than the first derivative. So you won't have a lot of problems on the assignment for this one because they do take a pretty long time to do. All right. You might be asked for, third, fourth, fifth derivative, but not on a problem that's complicated. On a problem like this, they would never ask more than second derivative. Now, they might ask you the fifth derivative of something that's just like sine x plus 3x squared or something. Something that is going to be quick to take the derivative of. But something like this, they wouldn't ask you anything past the second derivative. And as far as usefulness, second derivative, like past the second derivative, the applications become much more complex that we don't consider in this class, and I don't know anything about.
The derivative is slope, right? So we take the second, third, fourth derivative. Is that like a different slope in the graph?
It is, so you're finding the slope of the derivative graph. Well, so like, for example, Desmos will help answer that question a little bit, I think. I think it'll do it. Like, if I have f of x equals x plus 3 times x minus 5 times x plus 2. Like, that's a, let's make it show up better. So, like, that's like a cubic function. If I take the derivative of that, I think it'll do this. The derivative of that is a quadratic, right? So the slope of this at any point is given by this quadratic right here. So the slope is, the derivative is the slope of the tangent line, not the equation of the tangent line itself. Because if it were, then the third derivative or second derivative will always just be that number, right? So like if you take the derivative of the quadratic, that takes it down a notch. And so if I do, let's see if it'll do this. The second derivative is going to be a line. And if I did the third derivative, I don't know if it'll do that. It does. That's going to be just a horizontal line. And if I do fourth, it's 0, and then it stays 0 forever for that. So as far as the applications we're going to look at a lot of times our slope of a tangent line is going to be like our rate of change for something, particularly something maybe like velocity. So if I take the derivative twice, what I'm finding is the rate of change of the rate of change. The easiest, like most common application for that is if your original function is your position, your first derivative is velocity. So the derivative of velocity is the rate of change of velocity, which is acceleration. So first and second derivatives we will use a lot. Third derivatives do have applications. I know like a third derivative is in physics called a jerk. I only know this because I've seen math t-shirts that say don't be a third derivative. But like it does have some application, but as far as my knowledge of that, I don't know a lot other than it does exist. So you would definitely be studying this at a much higher level before you would really see applications for those third, fourth, fifth derivatives. But first and second derivatives we'll look at a lot for their application for that. All right, I need to go call the doctor real quick. So I want you guys to work on this problem for me while I go derivative. All right, so what do we need for this first part? Product rule. So we got to do, you can either keep the 3 out front or you can kind of group it with the x, either one. So I'm going to do 3x times the derivative of y, which is dy dx, plus y times the derivative of 3x, which is just 3. And then I've got to take the derivative of this 2x squared, so that'll be 4x. And then the derivative of 10y is 10 dy dx. Everybody okay there? All right. Now, all dy dx's go to one side. Other stuff goes to the other. So I've got 3x dy dx minus 10 dy dx equals negative 4x minus 3y, or negative 3y minus 4x, whichever way you want to write that. We will factor out our dy dx, which will be a 3x minus 10, and like this. So our final derivative should look something like this, negative 4x minus 3y over 3x minus 10.
So, like what I did was I subtracted 3x dy dx and kept, so that all that stuff was on the right side.
Okay. So do you have
I have
4x plus 3y
yeah,
over 10 minus 3x? This is okay. That is correct. So if you have that instead, because if you see, yeah, so like Luke moved everything to the right side instead of the left. So it basically changes the signs. Like if I took what I got right here and multiplied by negative 1 on top and bottom, which wouldn't change the value, then in the top I would get positive 4x, positive 3y. In the bottom, I'd get negative 3x, positive 10 here. So we would have that there. So Luke's is correct. Anybody else have something different they think might be correct? But because there can be a few different ways that.
Oh no, I was wrong.
Yeah.
I didn't think I was correct. I knew I was wrong.
Yeah. So it is okay to have either one of these. I might argue that Luke's is a little bit better right here because it has fewer negatives in it. So it might be a little bit easier to use his than the other. L time and third. Okay. I got seniors, so I'll have to look and see. I can't even remember what they're. Okay. Okay. That'll be great. Thank you so much. So, I need to tell her to give out my who's in Kendall and Miles. The candy bars I was supposed to give you yesterday are right here. So, in EHS time, tell Miss Moses to give those out for me because there's a good chance I'm going to be running around getting ready to leave and I'm going to forget. Give them out to you guys? I'm pretty sure. I'm pretty sure I'm not supposed to do that. Now. You were. Yeah. But you guys probably had EHS time teachers that have it together a little bit more than me. And they gave you yours yesterday.
Yeah, we got like gummy worms and gummy worms.
Now, see, my kids would pick that junk over chocolate. But I would pick chocolate every time. I would go chocolate every time. Like, my kids would pick gummy worms. That would be their favorite. Gummy worms and gummy bears and any kind of, like, sour something or, like, that stuff is their favorite stuff. Which is good for me because I want to eat all of their chocolate anyway.
I'm starting to pull back on chocolate. I was going sour for a while. Now chocolate's starting to come back.
Yeah.
I think I'm a chocoholic at heart.
Yeah, I definitely am. I can't have that stuff around here. That's one reason you guys don't get candy for prizes because I keep the bag over there in the closet and then I just eat it all. And then there's no candy left. And Hunter is not participating. He was not going to even before he sustained his head injury, but he's probably going to stay at the house since he's hurt. Henry is vending machine. So Yes. Henry, I think, chose this costume. Here, I'll email it to myself so I can show you guys. I am a little proud of it.
Wait, do you think it's possible to do a math problem with it?
With my vending machine costume.
What's the volume?
Oh, wait, that's cancel. Oh, wait, no, that's wrong. We are not, because we have one at our church that I got to be at. So I was gonna send Todd to take Henry to some more places besides just ours, but he is sick, so so he cannot do that. So probably we're just hanging out at the one at our church. Okay, I'm on this problem. All right, so I think I'll use the one that Luke got because it has a few less negatives. So if we take the derivative, the second derivative, then we will do quotient rule, 10 minus 3x. It's really important to have parentheses here. If you don't have parentheses, it doesn't turn out right. So you got to have those parentheses. And the derivative of this is going to be 4 plus 3 dy dx minus 4x plus 3y times derivative of the low, which is just negative 3, all over 10 minus 3x squared. But you cannot leave this in terms of the dy dx here. You got to have just x's and y's over here. So I'm going to write this over to the side for an FRQ. What you would want to do is just do 10 minus 3x times 4 plus 3 times, and right here you would put your 4x plus 3y. We'll run out of room really bad here. Minus 3x minus 4x plus 3y. That's all one line. Times negative 3 all over 10 minus 3x squared. So if it is a free response, even though I do need one more parentheses right there, if it is a free response, just plug in your dy dx and leave it from there. However, with this, if we are going to simplify this, it's going to be a little easier to multiply this out first before you put your dy dx in. Although it's not easy, it's still not. It's just a long problem. But so if we multiply here, we'll get 40 plus 30 dy dx minus 12x minus 9x dy dx. This negative is going to make that 3 a positive right there. So I'm going to change those to positives because that 3 really, we could put it like up here, and I'm going to distribute that 3. So we'll get plus 12x plus 9y all over 10 minus 3x squared. And when we do that, this negative 12x will cancel with the positive 12x. You can, but if you do, then you have to like distribute this 10 to this fraction over here. I think it's a little easier to do the distributing first and then do the dy dx. It is up to you on how you want to do that, because if you do put this here, you're going to have that fraction that you're having to distribute to, which is not the easiest, although it's not the easiest this way either. There's nothing about this problem that's easy, really. So now I would plug in the dy dx, so 40 plus 30 times 4x plus 3y over 10 minus 3x minus 9x times 4x plus 3y over 10 minus 3x plus 9y all over 10 minus 3x squared. These are those kind of problems you need to go home and show your mom and dad what you're doing. Alright, so if you want common denominators here, like all this is over 1. So these two right here are going to have the 10 minus 3x. This one needs the 10 minus 3x. And this one needs the 10 minus 3x. So we would have, oh gosh, 400 minus 120x plus 120x plus 90y minus 36x squared minus 27xy plus 90y minus 27xy. All of that is over 10 minus 3x, because we have the same denominator, and all of that is over 10 minus 3x squared. So, for that, we're going to combine anything we can in the top. We can put this over 1 and flip and multiply. So, 400 cannot go with anything. The negative 120 and positive 120x is going to cancel each other out. That's good. 90y and 90y is going to be 180y. Minus 36x squared, and then we got negative 27xy, and negative 27xy will be negative 54 xy. This is over 10 minus 3x times 1 over 10 minus 3x squared. So we're going to get 400 plus 180y minus 36x squared minus 54xy over 10 minus 3x squared. Nope, cubed. And they may do something like factor out a greatest common factor there in that numerator. But I don't believe that they'll take anything else out of that. Yeah, what could you take out? No, it's not divisible by 6.
Obviously it's by 2, but
Yeah, 2 definitely. Maybe 4. I think 4. It's 54 divisible by 4. No. Might just be 2. 3. I don't think 3 will go into 400. Yeah, either way, they might take it out. Certainly, like, if you get this far, you should be able to match it to an answer choice, because if they have taken out a greatest common factor, it's just going to be, I think 2 is probably the biggest number that will come out of this. So that will be about the best you can do. All right, so questions? All right, let me see what else I got. I think I've got one more. Okay, let's do one with some trig in it, and then I'm going to let you guys do your assignment. We are probably not going to do the inverse stuff today. Yeah. Okay. All right. Now, notice what they have here. They are asking for the second derivative, but what's different about what they're asking for? Derivative at 3 over pi. Okay, so they're asking for the derivative at a specific point. That is going to make this a little bit easier to deal with. So we need to find our first derivative to begin with. So what have I got to use for xy? Product rule. It's like the tiniest product rule you could have, but you have to have a product rule there. So you'll have x times dy dx plus y times the derivative of x, which is just 1, plus we got to do the derivative of cosine y, which is negative sign. So actually I'm going to make that a minus right there. Minus 3 sine y. You must put a dy dx with that, and that'll equal 0. Everybody all right here? Okay. All dy dx's stay over here on the left side. And that y is going to go over to the other side. It'll become a negative y. Factor out our dy dx. And then your last step is going to be to divide. I kind of don't like having that negative in the top. So here's something you can do. You don't have to do this at all. You can just leave it like this. But because you have that negative in the top, if you wanted, you could multiply by -1 on the top and on the bottom. And on the top, you would get a positive y. And on the bottom, you'll get negative x plus 3 sine y, which you can write like this: y equals 3 sine y minus x. You do not, by any means, have to do that. And on a free response, I would probably not, but you might see it on a multiple choice. It does make the next step just a teensy bit easier because you don't have as many negatives to deal with. So you might choose to do that if you want. All right, so we have our first derivative. Any questions so far? With the positive y? only slightly. You don't have to watch your negatives quite as closely because you don't have a negative in as many places. So slightly, you definitely don't have to do it that way. If we take our second derivative, okay, we're going to do quotient rule. We'll do low times the derivative of the high, which is dy dx minus high, times the derivative of the low, which is going to be derivative of sine is cosine, so that's going to be 3 cosine y times dy dx minus 1 all over 3 sine y minus x squared. Now, I am really not looking forward to simplifying this with all of that trig. So, when you're plugging a point in, you can avoid a lot of that. Because right here we've taken our derivative. It's not in terms of x and y yet. But when you're plugging a point in, it doesn't necessarily, you don't have to go to having everything in terms of x and y first. Because what's going to happen is whenever you plug in your point, it is going to be like this. So we've got the second derivative such that xy equals, what was it, 3 over pi as our points. All right. So that would look like this. We'll have, make sure you've got your parentheses right because it matters big time if you got your parentheses right. We've got 3 sine of pi minus x, which is 3 over pi. Now, dy dx is also going to have xy is 3 pi over pi. Then we'll have minus pi times 3 cosine pi times our dy dx such that xy equals 3 over pi minus 1 all over 3 sine of pi minus 3 over pi squared. Now, we could like plug in this with x and y's and plug that stuff in, but what I would prefer to do, so we've got these two places where we got this derivative with 3 pi over pi. What I would prefer to do is go up here and figure out what that is. So if I'm doing dy dx such that xy equals pi 3 over pi, that would be, in this case, our y, which is, oh, I've done this, hold on, no, I just wrote that backwards. That should be 3 over pi. Alright, so that is going to be pi over 3 sine pi minus 3 over pi. What is sine of pi? Is 0. So that 3 times 0 is going to go away. I'll have a negative 3 over pi. This is like pi over 1. So dividing fractions is easy as pi. Flip the second and multiply. Do I have that right? Yeah. The y was pi. Right? Yeah. Yeah. Okay, I flipped everything right there, didn't I? So I got negative pi squared over 3. So this is what I get when I plug 3 over pi into my first derivative. That can go here and here, rather than having to plug it in with all your x's and y's. So I'm going to give you guys a minute there to make sure you're with me. Look over it. It is kind of crazy. All right. Questions so far? All right, so what we're going to do is we are going to basically evaluate this as far as we can. We're going to plug in that negative pi squared over 3 for these. So what is sine of pi? 0. So this is just going to be 0 minus 3 over pi. So it's just going to be negative 3 over pi times negative pi squared over 3. That was what I had, right? Yeah. Minus pi times, what is cosine of pi? Negative 1. So that's going to be 3 times negative 1 times the negative pi squared over 3. And I'll still have that minus 1 over there. Over 3 sine pi is going to be 0. And then I'll have minus 3 over pi squared. Starting to look a little better. A little, maybe. Not quite as terrible as it once was. Definitely, if this is free response. FRQ, stop here. Okay, so if you have a free response, don't simplify that any further. Just make sure your parentheses all look good, that you've plugged things in like you're supposed to, and leave it, because you don't have to simplify. Now, you would have to go all the way to this step, because you have to plug in. You can't leave it where you've got this right here. You got to plug in that value that you got there. But if you get here, you can stop if it's free response. Let's continue on and simplify this a little bit more. Here, you got a negative times a negative here, so that's going to become positive. A 3 can cancel with that 3. Pi can cancel with one of these pi's, so you just get a pi right there. And then here, you've got a this stuff's like over 1, so you got a negative and a negative, that's going to make it positive. You got a 3 and a 3, those can cancel, so this is going to be a pi squared minus 1 here. Oh, this is looking so much better. I'm going to go ahead and square the top, square the bottom here. That's going to be 9 over pi squared. So, it's starting to feel somewhat manageable. Distribute your pi. So we have pi minus pi squared, pi cubed, plus pi over 9 over pi squared, which is going to give us 2 pi minus pi cubed over 9 over pi squared. And dividing fractions is easy as pi. Flip the second. Multiply 2 pi minus pi cubed times pi squared over 9. And that's over 1. So they are probably either going to distribute that and get 2 pi cubed minus pi to the 5th over 9, or they might like factor out an extra pi here, do pi to the 3rd times 2 pi squared, 2 pi minus, 2 pi minus, 2 minus pi squared over 9. Either way, terrible answers, right? Awful. Now, I will say, I don't think you're going to see anything quite this extensive on the exam. You see these, they are fairly extensive, not quite this far, usually, although some of them are fairly involved, and our book tends to be a little bit on the more difficult side maybe than I think what you'll see on the exam, but practicing what's in that book will definitely make it where you should be able to do what's in the exam there. Also, depending on where you go to school and what classes you have to take, you may have professors that like to, I know that Addison Blackwelder would send me pictures of some of his stuff from Calc 2 where he had, like, you know, the whole board filled up with some stuff. Jack would do the same sometimes with his Calc 2 stuff. So, you know, it's not easy, but you may have to, oh gosh, let's do an entire page. Look at that. Wow. That's a lot of work. Yeah. 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 So you might have to do some stuff like this. So it's good to practice it here in a fairly low risk environment where, you know, especially on homework, I'm not going to be angry with you if you don't get to the correct answer at the end. Because there